Hi there. I was watching the Radio Shop recently, and Buddy had on his bench a Heathkit crystal radio. I thought, well, I've made a few crystal radios over the years, and I thought, well, I could do a video on this one I've made. It was probably made about 15 years ago. And, well, I first started making crystal radios back in mid-late 70s when I was about 14. And in those days I was living at my parents' house, and it's a fairly big garden. So I had a 300-foot wire down the garden, and connecting that to the crystal radio with some high impedance headphones, you could hear the local Radio 4 transmitter on 198 kilohertz, which is probably the most powerful transmitter in the UK, 500 kilowatts, about 30 miles away. And that was enormously loud on headphones. And also you could get a few stations on medium wave as well. And also you could hear the French transmitter on 162, but they've turned that off sadly recently, like they're turning off a lot of long wave and medium wave stations, but Radio 4 is still going. And in those days when I was first built that crystal radio, living in my parents' house, as I said, it was very loud on headphones, and almost too loud. And I could also connect it to a loudspeaker. I had this old Goodman's 12-inch speaker. I think it was 15 ohm impedance. But I used a matching transformer, high impedance to low impedance matching transformer. And it was quite loud. You could listen to it quite comfortably, even on a speaker. Anyway, back to this one that I made a few years back. And as you can see, if I get something I can point with, it's a wooden box which I got at a car boot sale, and I had to cut it down to make it the right size. And the metal dial, which is cut out of a solid piece of brass sheet, and on the dial I've actually etched the station names. I don't know if you can see that. I've got Radio 4 there on long wave, and on the top scale on medium wave, Talk Radio, Radio Gloucestershire, Radio 5 Live and Radio Wales. That's the main stronger signals I get around here. And as I said, it's got a switch here for medium or long wave. I've got it on long wave at the moment because that's the strongest signal, 198, Radio 4. And earth terminal, an aerial terminal, and headphone terminals. I'm just using a 150-foot wire here because my garden's not as big as we had at my parents' place. And I've just got the earth connection going to the mains earth, and there's a earth stake outside, so that's fine. And it works very well, even on a 150-foot aerial wire. I don't know if I'm going to try and demonstrate how loud it is, but it is pretty loud on these headphones I'm using. I'm going to hold the earpiece of the headphones up to the microphone, and you can probably hear that. I tune it a bit because it's a bit off tune, that dial, and it's fairly loud. I mean, it's almost too loud. You're probably not hearing it as well as I can hear it on the headphones. And go over to medium wave. That might be Radio Gloucestershire around there. Not sure, I'll have to have a listen. That's Radio 5. Radio 5 is the next strongest apart from Radio 4. So that's quite comfortably loud to listen to. on headphones. And yeah, these are the headphones I'm using. I think these are fairly modern actually, probably from the 60s, but I think they're military headphones, but they're quite high impedance. I just measure them, put them. Right, just connected up to the multimeter. 1.2 k ohms resistance, so that's fairly high impedance. Also got these over here. These were advertised for sale in a radio magazine. I think it was Practical Wireless, and these are made by SG Brown, and that company is based in London. Used to make loads of headphones, high impedance, low impedance, whatever. And I don't know how old these are, probably 60s. But I asked the guy who was selling these if they were high impedance. He said, oh yeah, they're high impedance. When I got them, I found out they were actually only about 100 ohms. So what I did was, if I take the cover off, earpiece off, that's the, you can see the coils inside. I took that out, those coils out, and rewound them using wire off some old relays, very thin wire. Quite a job to do that was, and I got the impedance up to, I think, about 2.5k. Just measure these in a minute. I'll put that back on. Okay, I connected those up, and yeah, they're 2.5k ohms, and they work very well as well. In fact, they've got better bass response than the ones I first showed you. But I've got loads of old headphones I've picked up at various places. I'll show you some more. These are all high impedance. I think some of them are SG Brown again. Bought these at car boot sales, but none of them are that great. They work, but they're fairly old, and I think the magnets have lost some of their magnetism. So that's a problem with old magnets, I guess. But anyway, so that's about 5 pairs of headphones I've got. So back to this thing. I think I'll show you what's in it. Okay, so this is the insides of the crystal radio, and just looking for something to point with. As you can see, you've got a coil there. That's the medium wave coil. These came out of old transistor radio, and it's got a ferrite slug just to that's a ferrite rod that's been snapped off just to adjust the inductance, and tuning capacitor in the middle. Nice airspace, one out of an old radio. And the other coil is long wave coil. Switch, wideband switch different coils in and out. And over here we've got the germanium diode, and a small value 1.2 NF capacitor across the headphone output. It just sort of removes all the RF that's still on the audio signal. And don't know not much else to say about it really. Suppose we could have a look on the scope and see how much signal there is on the across the coil. I'll stick it back on long wave. Let's connect the scope. Just get the scope. Got the usual problem with the overhead light. I just turn that off. So I'm measuring 3 volts RMS at 198 kilohertz. You can see the modulation on the carrier wave. I can turn it down, you can see the audio modulation. So 3 volts, that's quite a big signal. Well, it would be. It's a 500 kilowatt transmitter. So I think we could actually look at it on the spectrum analyzer as well, because there's a low impedance tap on the aerial coil, and see what that looks like. Got a spectrum analyzer now connected across this low impedance coil, which is normally would be feeding the first stage of the RF amplifier on a radio. So let's have a look on the spectrum analyzer. Okay, this is the what it looks like on the spectrum analyzer on the low impedance part of that coil. I'm actually getting a massive signal, minus 20, minus 18. As I said, it's 500 kilowatt transmitter, so it is pretty big signal here. If I put that on trace on max hold, yeah, it actually goes up as far as minus 17. So that's a pretty impressively strong signal. And it would be a shame if they ever turn off this transmitter like they have done in Europe. But they keep saying they can't get the valves for it anymore. Well, they should convert it to solid state then, shouldn't they? Use MOSFETs, which I'm sure they could do if they could be bothered to do it and spend the money on it. It must cost a hell of a lot of money to keep it going though, 500 kilowatt transmitter. Anyway, could look at the audio output and see how much actual audio power is coming out of it. Okay, I now got the scope connected across the audio output of the headphones, and if we look down here, it's RMS voltage. It's probably peaking around 200 millivolts RMS. So just do a quick calculation. So it was 0.2 volts, and where's the squared button gone? There it is, squared, divided by impedance of the headphones 1.2k equals engineering, so that's 33 microwatts. That's all that was in the headphones, and although you couldn't hear it very well, it was very loud. So it's quite amazing how sensitive these old headphones are, and also how sensitive your hearing is. If you can hear a 33 microwatt audio signal, that's pretty low level signal. So guess that's about the end of the video. So hope somebody found it of interest. Thanks for watching.